Hello everyone. My name is Pragati Yadav, and our project is Smart Pantry, and I'm going to give an overview of our project. We have seen that it becomes a hassle to sit and write down which grocery items are missing before going shopping. It is the age of technology. Smartphones are taking over the world as they make people's lives easier. Keeping this fact in mind, we decided to not only make the process of grocery shopping easier, use the technology of phone applications to get rid of this everyday problem. So, the three main objective of a project is first to help you to know the ingredients in our pantry. Second, to recognize the quantity of the ingredient remaining in the pantry. Third, to reduce food waste by notifying the date of expiration. That's all from my side, and the further part will be explained by Pratik Shetty.
Hello everyone. Today I'm going to talk about the components we used in our project Smart Pantry. The main components we use are Arduino Uno, touch sensor and LCD display. Arduino Uno is a open source microcontroller board based on the 80 mega 328p. It has 14 digital input output pins, 6 analog inputs, a 16 MHz ceramics resonator, a USB connection, a power jack, an ICSP header, and a reset button. The second component we are using is the touch sensor. A touch sensor detects a touch or near proximity without relying on physical contact. So in our project Smart Pantry, we are using the touch sensor to detect the unit of ingredients kept inside the pantry. So whenever you add an ingredient or remove it from the pantry, the touch sensor detects it and signals it to the Arduino Uno, and then it gets displayed on the LCD screen. The third component we use is the LCD display. LCD display are a way to have your microcontroller talk back to you. They are useful in displaying alphabets, numbers, uppercase and lowercase letters. The LCD display will show you the updated list of ingredients inside the pantry. The next part will be explained by Ishani.
I'm ISHANI Mody, and I'll be briefing about the simulation of the circuit. This is touchpad, this is Arduino board, and this is LCD. We have connected touchpad to the analog pin A0 of Arduino Uno board. Pin 7 of Arduino Uno board is connected to pin 4 of LCD. Pin 5 of LCD is connected to ground. Pin 6 of Arduino Uno board and pin 6 of LCD are connected together. Pin 5 of Arduino Uno board connected to pin 11 of LCD. Pin 4 of Arduino Uno board is connected to pin 12. Pin 3 of Arduino to pin 13 of LCD, and pin 2 of Arduino to pin 14 of LCD respectively. So this is our code. We have defined our analog pin A0. We have included our library, which is a liquid crystal. In the first part, void setup, it is about displaying in the LCD. So the LCD is of 16 into 2, which means it has two lines of display, and each line can display 16 characters. So overall, it can display 32 characters. When the cursor is set in the range of 5 to 0, it will print force. And when the cursor is set in the range of 3 to 1, it will print dicto. And the delay time is 1000 milliseconds. The second part is void loop. This is for the execution of force applied on touchpad. So when the force is applied on touchpad, the analog pin will take analog readings from touch pin, and it will pass on to LCD. The range of weight will be between 0 to 10. When cursor is in the range of 4 to 0, it will print force, and the unit will be in kg. And when the cursor is in the range of 7 to 1, it will take back to the force, and it will display the numeric value of the force that is applied, and the delay time for the same is 500 milliseconds. On executing this code, so after compiling the code, we get this .ino.hex file, and we import that path of the .ino.hex file to this Arduino Uno board. And on saving this, when we perform the simulation, when we apply pressure towards the touchpad, the value in the LCD will increase, and when we apply pressure in the direction opposite to LCD, it will reduce the pressure. So that is it from our side. Thank you.